He's right there in my visor, and I can tell you, and I know you sense a little bit of the enthusiasm, but the things that NASA does in partnership with people all around the world is just the most amazing. I think the most amazing thing that people do on the planet. Really, really incredible. I stole these words. I mean, they're just a collection of 4 words, and I added one today. Actually, they came from an ad I saw in the newspaper. But innovate, explore, discover, and inspire. And I thought, hey, that's really what we do. We innovate. We use those innovations to go out and explore the cosmos. We discover things, and I think there's a human genetic reason why we love to discover things. That's why we're so successful. And then I think it's our mission to inspire. And in order to inspire, we have to communicate. And so I really appreciate the work you do. Astro is my Twitter name. And some interesting fact about me, other than the things you already know. I was in elementary school, probably 3rd grade. I used to go to 31 Flavors and get empty ice cream tubs and cut holes in them and make space helmets. So
That's nice.
I wanted to be a spaceman forever. I wanted to show this chart to you because it's a different way of looking at the kind of things Ellen described to you that we do. And so this is sort of the only sciencey chart I'm going to show, I think. And to me, this is the zen and the art of NASA science. It really tries to put it all into one piece. And so you can kind of start anywhere in this picture and get to all the other science that we do. And so this is, the graphic sort of shows everything in the universe. And really it starts at the moment of the Big Bang. And so that would be over here in cosmology, galaxy formation, evolution. In the Big Bang, hydrogen and helium was formed, a tiny bit of lithium. As the universe quickly expanded and cooled, the universe was kind of a lumpy but very dark and there was a lot of light flying around, but uninteresting place. And if that's all that the history of the universe involved, life would really be very uninteresting. And because it was hydrogen and helium, I don't know what kind of life helium would make, but we'd all talk very funny all the time. And so that wouldn't be that much fun. But as the material came together, started forming the first stars, the first galaxies. Inside of those stars, chemical elements in a nuclear furnace were created. The carbon, nitrogen, oxygen, and all the other chemical elements, like zinc, iron in our blood, calcium in our bones, was formed inside of those stars. That galaxy evolution, star formation, caused the material inside of those stars to explode in supernova explosions that made the heavier elements mixed up in molecular clouds from which planetary systems formed and our solar system formed. And in these molecular clouds, there's also photochemistry driven by ultraviolet light that creates organic elements. We can see that with our telescopes. And so that sometime after the Earth formed, there was a rain of water, a rain of organic components in this interstellar chemistry that allowed life to begin. We don't quite know that piece of the story yet, but astrobiology and life sciences outside of NASA were trying to figure that out, biological evolution, and we're studying other planets to understand their evolution, the planetary atmospheres. And so we get to some fundamental questions, which is, we go from the Big Bang all the way to life on Earth, and a lot of the discussion here at the American Geophysical Union is life sustainable on Earth? We're seeing very rapid climate change, we're seeing loss of biological diversity, changes in the Earth, and so that's a big question that we're asking. And then you heard about the great Kepler results, really phenomenal. I used to lay in the grass, look at the night sky as a teenager, wonder if anybody was out there. Story Musgrave on his shuttle flights tried to communicate with aliens. Thinking one would come by and then he would hitch a ride. Didn't work. I don't think it worked. And this question of are we alone? We are, I think, within a decade or two of finding an Earth twin around a very nearby star. And a next generation telescope after James Webb Space Telescope, or maybe one more. So in the 2030s, in principle, we have the capability to do spectroscopy of a planetary atmosphere of an Earth-sized planet around a nearby star and look for signs of interesting things going on. And that's not science fiction. That's what we could do, starting today if we wanted to, if the budget permitted, with today's technology. This is my favorite planet so far, and this is a picture from our SUMI satellite, National Polar Partnership, which is sort of the new blue marble. But what I believe is that NASA science is the greatest engine of scientific discovery on the planet. You look at the broad range of things that we do, from Icebridge, which just finished its mission in Antarctica, which was not a certainty. The government shut down, and the National Science Foundation said, well, I don't think we can support you, but we worked really hard, and when we came out of the shutdown, we were ready to go. We had supplies already in New Zealand, and off the team went to Antarctica for the first ever Icebridge mission, where we landed, in this case a NASA P-3, on an ice runway, rather than having to fly across the Southern Ocean from the tip of South America to do our mission. So that was a great mission. They just completed that. We have another part of Icebridge that's doing its mission in Greenland, in our airborne program, and then everything with a fleet of satellites around the Earth, and then of course all the things that we do, from exploring the planets, Messenger, Mercury, all of the satellites around Mars, and on the surface of Mars, Curiosity. These Curiosity results are really amazing, especially the connection to human spaceflight, the RAD results that show that an astronaut who had, if an astronaut rode along with the Curiosity rover after a year and then came back, you'd get about a sievert of radiation. And you might think, well, that's a lot of radiation. But actually, the estimate is that would increase your chance of getting cancer in your remaining lifetime by 5%. And NASA's rule is 3%. Well, that's an OSHA limit for radiation workers. I would certainly trade a risk of 5% cancer in my remaining lifetime to go to Mars and come back and bring samples and do geology on the surface. That's a small risk compared to the overall mission risk. So I think that's very, very promising. I'll say a little more about that later. We have Juno on its way to Jupiter. We have New Horizons on its way to Pluto. And you can ask me all the same questions you asked Ellen, because I thought they were great questions, and you'll get a little bit different color. But we have a new mission that's in development called JUICE, the Jupiter Icy Moons mission. And we're a major participant, but it's not our mission. It's a European Space Agency mission. They invited us to go to Jupiter with them. And so we've contributed a suite of instruments and are participating very, very closely with many other of their instruments. We have a U.S. science team working on that. So that's an example of how all of the partners that we have are working together to fly missions. And 80 to 90% of everything we do in the Science Mission Directorate is international. Of course, the main activity in the human spaceflight effort is the International Space Station, which is an international effort. So NASA really is trying to leverage everyone's capabilities as much as possible. In fact, I sort of feel like when we send people to Mars, it should be an international effort for a very simple reason. This will be the first time that humans have ventured to another planet that we could actually live on. So imagine that all the countries on planet Earth, this is a little bit fanciful, get together and decide to go to Mars, and one country is left out. How's that going to make them feel? Really lousy. And so this is different than I felt when I was in my 20s. I was like, the U.S. has to lead it, and we'll just go, because it's too much trouble to get everybody together. And I totally turned around to, this is really important that we go as a planet, not as an individual country in some kind of space race. So this is how we do it. And I'll just spend, I don't know, a minute on each of these spacecraft. So we launch a lot of spacecraft, we launch a lot of missions. We have aircraft, we have unmanned aerial vehicles, just all kinds of different ways of approaching the scientific problems. And we do have a very high cadence. People think, well, NASA's going out of business, but in fact, in science, we're just rocking. I mean, we have launches, frequently. This year in Earth Science alone, we have, 3 major missions going up. We're working on the James Webb Space Telescope, which is going to be even,